Hi guys, it's Mrs. Ross. I know that you guys are missing geometry, so here is section 4.2, so you don't have to go 9 days without your geometry fun. Um, there's another recording that goes over the last part of 4.1, so if you haven't watched that, go ahead and do that. And we are going to talk about section 4.2 today, which is a really great little section. I think it's going to feel really easy to you guys, like it makes sense. So it makes a lot of sense. We've talked about before, we've done a lot of things with congruent angles before, but now we're going to talk about not just if the angles are congruent, but what if the whole figure is congruent to each other. So first off, we're going to start off with a definition. So hopefully I will spell everything correctly. So congruent figure. So congruent angles, remember, is just kind of the fancy geometry way of saying equal. So in congruent figures, that's just basically like saying that figures, like a triangle is a figure, or a rectangle, or a quadrilateral, any of those things can be congruent to each other. So the definition, just so you have that written down, is in two congruent figures, all the parts of one figure are congruent, nothing like using the word to define itself, to the corresponding parts of another figure. Okay, so basically, when we have a figure, so we're going to focus on triangles and we'll maybe have some quadrilaterals, but when we have a figure, so we have these two triangles here, and we say that they are congruent, that means that all of the sides are congruent to each other, as well as all of the angles are congruent to each other, and the whole triangle is congruent to the other triangle. All right, so and remember, the sign for congruency looks like, if I can click on the right thing here. All right, computer. There we go. The sign of congruency, remember, is the equal with the little tilde over top. So that's a congruent figure. So you're going to see that a lot down here. All right, so we have an example here just to kind of drive home the point. What does it mean that all the parts of one figure are congruent to all the parts of another figure? All right, so we have two triangles here. We have triangle A, B, C, and triangle triangle A, B, C, and triangle F, G, H. And they look like they are congruent to each other. So we're going to identify all the pairs. And our two triangles that we have here are marked up like crazy. Remember, these marks actually indicate congruence as well. So one of the things that you want to do when you look at these, and they've done it off to the side here, is a lot of times it helps if you take the figure, and let's see if we can rotate it. Let's see. Close-ish. We can rotate it a little more. I was hoping that I could rotate it on a specific thing. You can see they rotated down here so that our lines actually match up and our angles match up, because it's easier if you can get your triangle, if they're congruent, to look the same, to just kind of see. All right, so they have actually done it nicely down here, so we're just going to pretend that we're able to do that. And we'll kind of work off this figure down here. So the first thing is that the whole triangle itself is congruent to each other. So triangle A, B, C, and this is where it becomes important, is congruent to triangle. Now, we know it's congruent to this triangle here, right? But we want to make sure that we write the letters in the same order so they correspond to the same angles. So what do I mean by that? Well, in triangle A, right? That's our right angle down here. So that corresponds to corner F in the second triangle, right? So triangle ABC is congruent to triangle F, and then the next letter they do is B, okay, B. And you can see that B right, is congruent to G. So it will be F, G, and then our last letter is C. C, you see, has two lines down up here at the top, and angle H also has two lines. So triangle FGH. So this is a true statement. In the diagram, we can say that triangle ABC is congruent to triangle FGH. So just be careful that you don't randomly say, well, I know it's that, so it's congruent to HFG. Okay, that does not work because we haven't matched up our angles to each other and our sides don't correspond to each other. Now, if you get this right, the triangle congruent statement right, then it actually makes all of your other work even easier. So what do I mean by that? Okay, we'll take that off there because it's messy. So we know that the two triangles are congruent to each other. Let's talk about the angles, which angles are congruent to each other. Okay, so angle A, right, is our right angle. And that one's pretty easy to tell on here, is congruent to angle F, right? Because those are my two right angles. And you'll notice that in my position, angle A, A is the first term that I note in my triangle, and F is the first term. So they should match up in your triangle statement if your angles match up. Okay, now I look at angle B. So angle B, I've all marked up down there. Angle B is the one with one line, and that corresponds to, that's congruent to angle G. All right, and then the last one is we have angle C, which has two lines, and that is congruent to angle H. And you'll see this kind of matches up here, right? B is in my second slot and G is in my second slot. So B and G are congruent. C is in my third slot and H is in my third slot. So that matches up for congruent statements. Okay, now that I have all kinds of marks on here, let's talk about the sides of my triangle. Okay, so I have line AB, which is this one right here. And what is that congruent to? Line AB is congruent, and you can tell because they both share those two little lines, to line FG. It's kind of hard to see. Line FG. Okay. Again, if you look up here at my statement, this is why their triangle statement is so important. A and B are next together, and F and G are next together. So they kind of match up. I'm going to switch colors. Now, what about line BC? BC is right here. It has three congruent lines on it. And that corresponds to line GH. I'm going to write it below because I'm running out of room. Line GH. And again, if you look at B and C, they're stuck together up here, and G and H are stuck together. So that's why I said if you get this triangle thing right, then that helps you with all the rest of your congruent statements. All right, the last one I have is line CA, which is over here, and that is congruent to line HF. Okay, this one's a little bit trickier. So CA is my last and then my first, and that corresponds to HF. So we have two congruent triangles, and so that means that the triangles are congruent. It means that all the angles are congruent, and it means all my sides are congruent. Everything is true all together. Okay, so let's do a little exercise with this. Let's pull out example number 2 and see what we can do here. Paint, that's what I'm looking for. Okay, so we have two, these are not triangles, they're quadrilaterals, right? They're four-sided figures. They're not a specific four-sided figure. And they tell us that QRST is congruent to WXYZ. Okay, so the way that they've had these written is that they don't actually have them in the same orientation. So what I'm going to try to do is I'm going to move this here, and I think this is actually going to work. Rotate it 180 degrees. Yes, it did work. Now, We have our letters upside down, but at least our two figures are the same. Now, how can if this one you can actually look at, even though the second one is upside down letters, but this one you can actually look at. But the other way that you can double check yourself is go back to this statement. So angle Q over here, right, is in my first spot. Angle Q over here is what I was trying to indicate. And that means, and angle W is in my first spot here. So angle Q should be congruent to angle W. So that checks out, right? And, angle T is in my last spot. And if I can get it to right. And angle Z is in my last spot. So that means that T is congruent to Z, and that checks out. And then R and S obviously check out with X and Y. So I know that I flipped it the right way because if I look back at my original statement and I check out where my new spots are, then it checks out. Now, let me actually write these right side up. Okay, and this angle right here is 5x plus 5. All right, so the first thing I want to do is find the value of x. Well, I know that my two quadrilaterals are congruent to each other. And that also means that, and I already mentioned it, right? Angle Q is congruent. So angle Q is congruent to angle W. All right. Well, if angle Q is congruent to angle W, I know angle Q is 65 degrees. And I know that angle W, even though it's written upside down, is 5x plus 5 degrees. And if two angles are congruent, that means they're equal to each other. So I can just set my two angles equal to each other. All right, so let me solve for x by subtracting 5 from both sides. I get 60 equals 5x. Divide both sides by 5, and I get x equals 12. So I've solved for x. So x equals 12. Okay. All right, that's awesome. So we solved for that. Now, I need to solve for y. Okay, let's pick a different color for y. Y, I know you're probably looking at your screen upside down, but y there is the distance between W and X is Y minus X inches. Okay. And now we know what X is, so we can figure out what Y is. Well, let's talk about, we used congruent angles to solve for X. Let's use congruent sides to solve for Y. Okay. So let's look at what sides are congruent. I know that my sides that are congruent that I can use is WX over here. WX, right? That side WX is congruent to this side over here. And if I look at my equation, WX are my first two letters here, so WX should be congruent to side QR. Okay, and thankfully they told me what QR. QR is 6 inches. 6 inches. And WX is Y minus X. And we know that X is 12. So Y minus 12 equals 6. Add 12 to both sides. And I get Y equals 18. All right, so that's fun with congruent figures, right? Everybody's having fun, right? All right, so let's do a couple more examples here. Just to make sure that we have it. I think the next one's actually easier than this one. I think we kind of started off with the tricky one, but let's double check. Oh yeah, this one's easier than the other one. So, all right, so we have two quadrilaterals here, right? And it says identify all pairs of congruent corresponding parts. So we have corresponding angles and corresponding sides. And what they should have told us is that the two figures are congruent to each other. So we know that they're congruent to each other. They just didn't do a very good job of telling us that. All right. All right. So again, I'm going to try rotating this. See, that didn't help me very much. I need to kind of like rotate it a little bit, bust out my Photoshop skills, right? So this is a little bit closer. Let's see. Kinda. You're going to have to kind of scrunch your head sideways, but this is not quite so sideways. So the thing is, if I can start off and I can write a congruent statement that's true for the whole figure, then that makes all the rest of my job super easy. So what do I mean by that? If I can say that if I can actually get my thing to work here. If I can say that JHGF is congruent, and I can get this right, what it's congruent to, then everything else becomes easy. All right, so what do I mean by that? J is my angle that's down here, that's to the left of my right angle. So J corresponds to V. Okay, those two angles are the same. Then next I have H, and H is easy because that's my right angle. So H corresponds to U. Okay, and then above that angle, I have T. T corresponds to G. And then lastly, I have F, which corresponds to S. Looks like some cryptic word, right? JFGH is congruent to VUTS. Now, I could sit there and tell you all the corresponding angles by looking again and doing the same thing, or I just know that angle J is congruent to angle V because they're in the same spot. And I know that angle H is congruent to angle U because they're in the same spot in my correspondence statement. Again, you can look at the figure to help you out too, right? I know that angle, I'm going to run out of room. I know that angle, well, that's what happens when you change that color. All right, I know that angle G is congruent to angle T. And I know that angle F is congruent to angle S. So I know all those things to be true, right? Sides are the same thing. I could sit there and look and say, okay, JH is here and that's equal to VU. Or I can just use my statement. So JH, right, is congruent. So JH is congruent to VU. HG is congruent. HG is these two, right? Is congruent to UT. GF is congruent to TS. And last but not least, this is the trickiest one to do, FJ is congruent to SV. So those will be all of my congruent statements. Okay. All right, so we did all that. Now, last up, let's find the value of X and find the measure of angle G. Okay, so we want to figure out what is X and what is the measure of angle G, and we just happen to already have figured out that G is congruent to angle T. Okay, and angle T is 103 degrees. So this should be actually pretty easy. I don't know. I don't know what's going on with me today in colors. All right, so we know that angle G is congruent to angle T. And angle T is 103 degrees. All right, so let's fill in the blanks. So angle G is 2x minus 7, and angle T is 103 degrees. So I'm going to add 7. I'm going to solve for X now. So 2x equals 110, or X equals 55. So we solved for X, right? Now, that's finding X. What is the measure of angle G? The measure of angle G is exactly the same as the measure of angle T. So that should be 103 degrees. Okay, so that is fun with congruency. We've got but wait, there's more. We actually have some theorems. This theorem is super easy. It will totally make sense when you see it, called the third angles theorem. Okay, if you have two angles of one triangle and they're congruent to the two angles of another triangle, then the third angles are also, dun, 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 I put a congruent. It's like the most popular answer, right? So this makes sense, right? You have two triangles. We just talked about in 4.1 how every triangle adds up to 180 degrees. So if angle B, I always do that, angle B is congruent to angle E, and angle A is congruent to angle D, then guess what? C is congruent to F. And I think this just makes sense, right? Because we know all triangles add up to 180 degrees, and 2 out of the 3 are exactly the same on both triangles, that means that the third one is going to be the same as well. So I think this is a pretty easy theorem to understand. So you just basically need the fact that two angles are congruent to each other to show that they are congruent. Okay, and then, but wait, there's more. While you have your theorem sheet out, we have theorem 4.3, and then we'll go back and do example 4. Okay, theorem 4.4. These will look very familiar, especially if you're studying for, chapter 3 stuff. We have properties of congruent triangles. So here we have 3 triangles. We have A, B, C, D, E, F, and J, K, L. All right, so you're going to recognize these words because we have definitely used these words before to describe the relationship between angles, the relationship between lines, and now we're going to talk about the relationship between triangles. So remember, the reflexive property is kind of the one that doesn't help us out that much. The reflexive one just says if I have any triangle ABC, triangle ABC is congruent to triangle ABC. The reflexive one, kind of helpful, right? Not too bad. All right, then we have the symmetric property. So remember, symmetry is like when something is equal on both sides. So this says if ABC, triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. And I think this makes sense, right? If this triangle is congruent to this triangle, then this triangle is congruent to this triangle. It works both ways. That's a symmetric property. All right, so then the last one is probably the one we use the most, transitive property, right? So transitive says, we'll switch colors. Transitive says that ABC is congruent to DEF, and DEF is congruent to JKL, then ABC is congruent to JKL. All right, so ABC is congruent to DEF, DEF is congruent to JKL, so triangle ABC is congruent to triangle JKL. There we go. All right, one last problem, and then I will send you on your way because I know you don't want to miss out on any more fun. All right, we are going to actually we're going to use the theorem that we just learned about the third angle theorem, so 4.3, to do a little proof here, okay? So use the third angles theorem. So we have this figure here. We have two triangles that kind of overlap each other, right? And we need to find the measure of angle V. Okay. So let's take a look at what we've got going on here. We have these two triangles. You can also kind of break them out into two triangles if it's hard to look at them like they are. So we could actually draw one triangle this way and draw, okay, we'll leave that there, and then draw the other triangle the other way. Oops, it won't let me do that. Can I flip it? There we go. All right, so these two are supposed to be the same triangle. So I'm kind of breaking apart this triangle that we have. So we have S, and now I'm just drawing random triangles. We have S, T, W, okay? And we know that angle, okay, we have STW and we have VWT. All right, and then there's a triangle that's inside the triangle that this is 66 degrees right here. If I can get it to right, that's 66 degrees. And this little triangle right here is 44 degrees. Okay, and then we have a similar triangle over here, which is congruent to here. So this means that W, this little one, is also 66 degrees. So I don't know, we could use either figure. I think maybe just kind of pulling them apart might help a little. And actually, now that I'm looking at it, I don't know if it will, but let's just see. So we're trying to figure out up here, what is the measure of angle V? All right, so the first thing that we know is that, well, the first thing that they start off with is the fact that SUT, so angle SUT, is congruent to angle VUW. So we know that these two angles that I just drew are congruent to each other. And why do we know that those two are congruent to each other? Well, we know that those two are congruent to each other because of a rule we learned a long time ago called the vertical angles. Vertical angles. Okay, vertical angles. So we know that this angle is congruent to this angle right here. That means they're both 44 degrees, right? The diagram shows that angle STU, so we're on the second line here, STU is congruent to, and it shows by this little, the reason they're saying the diagram says it is because we have these little congruent angle marks, right? So it's saying that STU is congruent to angle VWU, and that's just shown because of these little hash marks there, okay? So now we have two triangles here, and we didn't need to do this over here, I apologize. We have two triangles shown by this red lines here. We have two triangles, and we have two angles that are equal to each other. So we have the red angles are equal to each other and the black angles are equal to each other. So we can say that because of theorem 4.3, the third angles theorem, we can say that angle S is congruent to angle V. All right, so that means if we can solve for angle S, we can solve for angle V. Well, if we look at this one triangle over here and we kind of pull this out, we have STU. This angle here is 66 degrees. This angle is 44 degrees, right? And so that means that angle S is 44 plus 66 plus measure of angle S. Those added together equal 180 degrees because every triangle adds up to equal 180 degrees. So if you want to fill in the blanks, it's 180 degrees minus 44 minus 66. So if I do that, I get 70 degrees. Angle S is 70 degrees. So if the measure of angle S is 70 degrees, then the measure of angle V is also 70 degrees. And that's by the definition of congruent angles. Okay? So that was a lot of fun. That was kind of the trickiest example. If you go and see your homework, you're going to be just looking at congruent angles and trying to figure out kind of which ones match up to each other. So check that out and come back to me with any questions next Thursday. Hope you guys have an awesome week. Bye. Maybe.